have a catch-all video for section 9.4 all the way to 9.6, which is talking about derivatives. So before we get started, just a reminder that if you're given a function f of x, then the derivative is the slope of the tangent line, which is the same thing as the instantaneous rate of change. So if any questions ask you, find the slope of the tangent line and find the rate of change, they're actually asking for the exact same thing. Also, what I would like to point out is that the instantaneous rate of change, aka the derivative, can either be written like this, which is f prime of x, or dy over dx. Remember, because we're talking about the slope, we're talking about the change in y over the change in x, and when you're looking at something like physics, they usually denote change with a delta, which is a Greek letter d. So this is like delta y, or the change in y, over the change in x, which is the slope. So the derivative rules that you have learned so far is that if you take the derivative of a constant, so c is always going to denote some real number, it's going to be 0. So for example, if we wanted to find the derivative of, let's say, 5, that derivative would equal 0. Remember, if you draw a graph of just the function 5, it's going to be a straight line, so it's going to have a derivative of 0. Now, if you're multiplying a function by a constant, then that constant's just going to stay out in front, and then you're going to take the derivative of the function and multiply them together. I'll show you what that means in the next rule. The next rule is the power rule, which says if you have x to the n, then what you do is that you're going to take that exponent, bring it down and multiply it in front, and then subtract 1 from that exponent. So for example, if you want to find the derivative of, let's say, 3x to the 5th, then what you're going to do is that you're going to bring that 5 down in front, so it would be 5 times 3x, and then we have to subtract 1 from that exponent, so it would be to the 4th. So that would be 15x to the 4th would be our derivative function. If you're adding or subtracting two functions from each other and you're taking the derivative, then you can take the derivative of each and just add them together. So if you want to take the derivative of, let's say, x to the 3rd plus 5, well, since these are adding together, I can just take the derivative of each piece. So that'll be 3x squared, because you take that power, bring it down in front, and subtract 1 from it, plus 0. Now when you're doing this on the homework, if it's a constant like plus 0, you don't really need that. You can just write 3x squared. Same thing if they're subtracting. Now, if you're multiplying two functions or dividing two functions, you have to do a completely different rule. So what this rule says is that you're going to leave the first function alone, multiply it by the derivative of the second function, then add it to the first function left alone times the derivative of the second. We'll do one of those examples a little bit later. Now for the quotient rule, I actually have a ridiculous song for that. It is the bottom times the derivative of the top minus the top times the derivative of the bottom, all over the bottom squared. So you're going to leave g of x alone, multiply it by the derivative of the top, then subtract the top left alone times the derivative of the bottom, and then when you divide it, you're leaving that bottom alone, but you're squaring it. Alright, the very last rule that we're going to have here is the chain rule. So what you do with the chain rule is you're going to have one function inside of another function. And what you're going to do is you're going to take the derivative of the outside function, leave the inside function alone, and then multiply by the derivative of the inside function. This notation is a little bit different than what you'll see in your book. Inside your book, you're going to see something that looks more like this. It'll be f of u of x, and it will say f prime of u times u prime. So they mean the same thing, they're just different ways of writing them. Alright, let's go ahead and do this first example. And we're going to do example 1 and 2, and then we're going to go ahead and create another video to do the rest of these, because they're a little bit more involved. So, first off, it wants us to use the definition of the derivative to find the equation of the tangent line at f prime of 2 for the function f of x equals 3 minus x squared. So anytime you're asked to use the definition of the derivative, you are going to use the fact that it's the limit as h approaches 0 of f of a plus h minus f of a all divided by h. Remember, that equals f prime of a. In our case, this means that our a value equals 2. So we're going to have the limit as h approaches 0 of f of 2 plus h minus f of 2 all divided by h. So if I take 2 plus h and I plug that into my function, so remember, that means I'm taking this guy, and everywhere I see an x in my function, I'm going to plug that in. I'm going to get 3 minus 2 plus h squared, so that's only this first part, minus, and then f of 2 would be 3 minus 2 squared, so that'd be 3 minus 4, which would give me a negative 1. All divided by h, and then I totally forgot to put my limit, so let's put that right there. Alright, now if I expand this out, I'm going to get the limit as h approaches 0 of 3 minus 4 minus 4h minus h squared, let's see, plus 1, all divided by h. Now what's going to happen is that 3 minus 4 is going to be a negative 1. That negative 1 is going to cancel out that positive 1. This h is going to cancel out with these h's here. So what I'm going to be left with is negative 4 minus h, which if I take the limit as h approaches 0, is going to give me negative 4. Perfect. Now, the rest of the problem actually wanted me to find the equation of the tangent line at that point. So remember, the equation for the tangent line is y equals mx plus b. Okay, so in this case, that negative 4, remember the derivative is the slope of my tangent line, so that's my m. That's this guy right here. My y value is what I'm going to get if I plug 2 into my original function. So that's going to be negative 1 equals negative 4 times 2 plus b. So let's see, that's going to give me negative 1 equals negative 8 plus b. So I will get y equals negative 4x. Let's see, if I want negative 8 plus b to equal negative 1, that would be plus 7. Perfect. Now, before we get started on the rest of these problems, let's say that you just wanted to make sure that you checked your work. So the way that we just did this was the very, very long way. Okay? So this is the very long way using the definition. However, if you wanted to do this using the shortcuts that we learned before, or not before, but in section 9.4, is, well, f prime of x would be 0, because that's the derivative of 3, minus the derivative of x squared, which would be 2x, which would just give us a negative 2x. So if I wanted to know what f prime of 2 was, that would be negative 2 times 2, which would still give us negative 4 like we did before. The whole reason that we come up with these derivative rules is because they allow us to go really quick. Alright, so let's use these derivative rules to find these derivatives below. So, if I want to find the derivative of y equals t cubed, well then the derivative, dy over dt, is going to be 3t squared. Now on the next one, if I want to find the derivative of f of x equals 4x squared minus the square root of x, Well, that square root of x is kind of messing me up a little bit, but we can rewrite that as 4x squared minus x to the 1/2 power. So when I take the derivative, I'm going to do the same thing I've been doing before. So f prime of x is going to be, so I bring that 2 down in front, that'll be 8x, because 2 times 4 is 8, minus, I'm going to bring that 1/2 down in front, x, and remember the derivative rule says that I still need to subtract 1 from that, so it'll be negative 1/2. Alright, now on the next one, we're going to have h prime of x equals, so we're going to bring that 2 and bring it out in front, so 1/2 times 2 will give us 1, and that's a negative, so it'll be negative x plus the derivative of this guy, which will be 3/5 x to the, well, we still need to subtract 1 from that, so that would be negative 2/5 minus, and the derivative of 0, because it doesn't have an x attached to it, it's going to be 0, so the derivative of 17 is 0. Alright, just some quick little things to note. If you have the nth power, or I'm sorry, the nth root of an x, you can rewrite that as x to the 1 over n. Okay, and if you have 1 over x to the n, you can rewrite that as x to the negative n. These make it a lot easier if you look at something and you're not sure if you can use the power rule. Then what you can do is you can rewrite them like so, and then you can use the power rule. So that's it for those examples. We're going to look at examples 3 and 4 in the next video.